Blaise Pascal, French, Blaise Pascal. The 19th of June 1623 to the 19th of August 1662, was a French mathematician, physicist, inventor, writer and Christian philosopher. He was a child prodigy who was educated by his father, a tax collector in Rouen. Pascal's earliest work was in the natural and applied sciences, where he made important contributions to the study of fluids, and clarified the concepts of pressure and vacuum by generalizing the work of Evangelista Torricelli. Pascal also wrote in defense of the scientific method. In 1642, while still a teenager, he started some pioneering work on calculating machines. After 3 years of effort and 50 prototypes, he invented the mechanical calculator. He built 20 of these machines, called Pascal's calculators and later Pascalines, in the following 10 years. Pascal was an important mathematician, helping create 2 major new areas of research. He wrote a significant treatise on the subject of projective geometry at the age of 16, and later corresponded with Pierre de Fermat on probability theory, strongly influencing the development of modern economics and social science. Following Galileo and Torricelli, in 1646 he refuted Aristotle's followers who insisted that nature abhors a vacuum. Pascal's results caused many disputes before being accepted. In 1646, he and his sister Jacqueline identified with the religious movement within Catholicism, known by its detractors as Jansonism. His father died in 1651. Following a mystical experience in late 1654, he had his second conversion, abandoned his scientific work, and devoted himself to philosophy and theology. His 2 most famous works date from this period, the Lettres Provinciales and the Penns, the former set in the conflict between Jansonists and Jesuits. And this year, he also wrote an important treatise on the arithmetical triangle. Between 1658 and 1659 he wrote on the cycloid and its use in calculating the volume of solids. Pascal had poor health, especially after his 18th year, and his death came just 2 months after his 39th birthday. Early life and education. Pascal was born in Clermont-Ferrand. He lost his mother, Antoinette Begon, at the age of 3. His father, Etienne Pascal, 1588 to 1651, who also had an interest in science and mathematics, was a local judge and member of the noblesse du robe. Pascal had 2 sisters, the younger Jacqueline and the elder Gilbert. In 1631, 5 years after the death of his wife, Etienne Pascal moved with his children to Paris. The newly arrived family soon hired Louise Delfault, a maid who eventually became an instrumental member of the family. Etienne, who never remarried, decided that he alone would educate his children, for they all showed extraordinary intellectual ability, particularly his son Blaise. The young Pascal showed an amazing aptitude for mathematics and science. Particularly of interest to Pascal was a work of Desargues on conic sections. Following Desargues' thinking, the 16-year-old Pascal produced, as a means of proof, a short treatise on what was called the mystic hexagram, Essai pour l'économique, Essay on conics, and sent it his first serious work of mathematics to Perrins in Paris. It is known still today as Pascal's theorem. It states that, if a hexagon is inscribed in a circle, or conic, then the 3 intersection points of opposite sides lie on a line, called the Pascal line. Pascal's work was so precocious, that Descartes was convinced that Pascal's father had written it. When assured by Mersenne that it was, indeed, the product of the son not the father, Descartes dismissed it with a sniff. I do not find it strange that he has offered demonstrations about conics more appropriate than those of the ancients, adding, but other matters related to this subject can be proposed that would scarcely occur to a 16-year-old child. In France at that time offices and positions could be and were bought and sold. In 1631 Etienne sold his position as second president of the Courtisates for 65,665 livres. The money was invested in a government bond which, provided if not a lavish then certainly a comfortable income which allowed the Pascal family to move to, and enjoy, Paris. But in 1638 Richelieu, desperate for money to carry on the 30 Years' War, defaulted on the government's bonds. Suddenly Etienne Pascal's worth had dropped from nearly 66,000 livres to less than 7,300. Like so many others, Hen was eventually forced to flee Paris because of his opposition to the fiscal policies of Cardinal Richelieu, leaving his 3 children in the care of his neighbor Madame Saintet, a great beauty with an infamous past who kept one of the most glittering and intellectual salons in all France. It was only when Jacqueline performed well in a children's play with Richelieu in attendance that Hen was pardoned. In time Hen was back in good graces with the cardinal, and in 1639 had been appointed the king's commissioner of taxes in the city of Rouen, a city whose tax records, thanks to uprisings, were in utter chaos. In 1642, in an effort to ease his father's endless, exhausting calculations, and recalculations, of taxes owed and paid, Pascal, not yet 19, constructed a mechanical calculator capable of addition and subtraction, called Pascal's calculator or the Pascaline. The Mercedes Arts et Métiers in Paris and the Zwinger Museum in Dresden, Germany, exhibit 2 of his original mechanical calculators. Though these machines are early forerunners to computer engineering, the calculator failed to be a great commercial success. Because it was extraordinarily expensive, the Pascaline became little more than a toy and status symbol for the very rich both in France and throughout Europe. However, Pascal continued to make improvements to his design through the next decade and built 20 machines in total. Contributions to mathematics. Pascal continued to influence mathematics throughout his life. His Traité du triangle arithmétique, treatise on the arithmetical triangle of 1653, described a convenient tabular presentation for binomial coefficients, now called Pascal's triangle. The triangle can also be represented 0 1 2 3 4 5 6 0 1 1 1 1 1 1 1 1 1 2 3 4 5 6 2 1 3 6 10 15 3 1 4 10 24 1 5 15 5 1 6 6 1. He defines the numbers in the triangle by recursion, call the number in the m plus 1, th row, and n plus 1, th column tmn. Then tmn equals tm1, n plus tm, n1, for m equals 0, 1, 2, and n equals 0, 1, 2. The boundary conditions are tm, 1 equals 0, t1, n equals 0 for m equals 1, 2, 3, and n equals 1, 2, 3. The generator T00 equals 1. Pascal concludes with the proof. In 1654, prompted by a friend interested in gambling problems, he corresponded with Fermat on the subject, and from that collaboration was born the mathematical theory of probabilities. The friend was the Chevalier de Maillet, and the specific problem was that of 2 players who want to finish a game early and, given the current circumstances of the game, want to divide the stakes fairly, based on the chance each has of winning the game from that point. From this discussion, the notion of expected value was introduced. Pascal later, in the Penns, used a probabilistic argument, Pascal's wager, to justify belief in God and a virtuous life. The work done by Fermat and Pascal into the calculus of probabilities laid important groundwork for Leibniz's formulation of the infinitesimal calculus. After a religious experience in 1654, Pascal mostly gave up work in mathematics. Philosophy of mathematics. Pascal's major contribution to the philosophy of mathematics came with his De l'esprit géométrique, of the geometrical spirit, originally written as a preface to a geometry textbook for one of the famous Petites Écoles de Port Royal little schools of Port Royal. The work was unpublished, until over a century after his death. Here, Pascal looked into the issue of discovering truths, arguing that the ideal of such a method would be to found all propositions on already established truths. At the same time, however, he claimed this was impossible, because such established truths would require other truths to back them up. First principles, therefore, cannot be reached. Based on this, Pascal argued that the procedure used in geometry was as perfect as possible, with certain principles assumed, and other propositions developed from them. Nevertheless, there was no way to know the assumed principles to be true. Pascal also used De l'esprit géométrique to develop a theory of definition. He distinguished between definitions which are conventional labels defined by the writer and definitions which are within the language, and understood by everyone, because they naturally designate their referent. The second type would be characteristic of the philosophy of essentialism. Pascal claimed that only definitions of the first type were important to science and mathematics, arguing that those fields should adopt the philosophy of formalism as formulated by Descartes. In De l'art de persuader, on the art of persuasion, Pascal looked deeper into geometry's axiomatic method, specifically the question of how people come to be convinced of the axioms upon which later conclusions are based. Pascal agreed with Montaigne that achieving certainty in these axioms and conclusions through human methods is impossible. He asserted that these principles can be grasped only through intuition, and that this fact underscored the necessity for submission to God in searching out truths. Contributions to the physical sciences. Pascal's work in the fields of the study of hydrodynamics and hydrostatics centered on the principles of hydraulic fluids. His inventions include the hydraulic press, using hydraulic pressure to multiply force, and the syringe. He proved that hydrostatic pressure depends not on the weight of the fluid, but on the elevation difference. He demonstrated this principle by attaching a thin tube to a barrel full of water, and filling the tube with water up to the level of the third floor of a building. This caused the barrel to leak, in what became known as Pascal's barrel experiment. By 1646, Pascal had learned of Evangelista Torricelli's experimentation with barometers. Having replicated an experiment that involved placing a tube filled with mercury upside down in a bowl of mercury, Pascal questioned what force kept some mercury in the tube, and what filled the space above the mercury in the tube. At the time, most scientists contended that, rather than a vacuum, some invisible matter was present. This was based on the Aristotelian notion that creation was a thing of substance, whether visible or invisible, and that this substance was forever in motion. Furthermore, everything that is in motion must be moved by something, Aristotle declared. Therefore, to the Aristotelian-trained scientists of Pascal's time, a vacuum was an impossibility. How so? As proof it was pointed out. Light passed through the so-called vacuum in the glass tube. Aristotle wrote how everything moved, and must be moved by something. Therefore, since there had to be an invisible something to move the light through the glass tube, there was no vacuum in the tube. Not in the glass tube or anywhere else. Vacuums, the absence of any and everything, were simply an impossibility. Following more experimentation in this vein, in 1647 Pascal produced experiences nouvelles touchant la vie, new experiments with the vacuum, which detailed basic rules describing to what degree various liquids could be supported by air pressure. It also provided reasons why it was indeed a vacuum above the column of liquid in a barometer tube. On the 19th of September 1648, after many months of Pascal's friendly but insistent prodding, Florin Peyrier, husband of Pascal's elder sister Gilbert, was finally able to carry out the fact-finding mission vital to Pascal's theory. The account, written by Peyrier, reads: "The weather was chancy last Saturday, but, around 5 o'clock that morning, the Puy de Dôme was visible, so I decided to give it a try. Several important people of the city of Clermont had asked me to let them know when I would make the ascent. I was delighted to have them with me in this great work. At 8 o'clock we met in the gardens of the Minim Fathers, which has the lowest elevation in town. First I poured 16 pounds of quicksilver into a vessel, then took several glass tubes, each 4 feet long and hermetically sealed at one end, and opened at the other, then placed them in the vessel of quicksilver. I found the quicksilver stood at 26 3 lines above the quicksilver in the vessel. I repeated the experiment 2 more times, while standing in the same spot. They produced the same result each time. I attached one of the tubes to the vessel, and marked the height of the quicksilver, and asked Father Chastin, one of the Minim brothers, to watch if any changes should occur through the day. Taking the other tube and a portion of the quicksilver, I walked to the top of Puy de Dôme, about 500 fathoms higher than the monastery, where upon experiment, found that the quicksilver reached a height of only 23 inches and 2 lines. I repeated the experiment 5 times with care, each at different points on the summit, found the same height of quicksilver, in each case. Pascal replicated the experiment in Paris, by carrying a barometer up to the top of the bell tower at the church of Saint-Jacques de la Boucherie, a height of about 50 meters. The mercury dropped 2 lines. In the face of criticism that some invisible matter must exist in Pascal's empty space, Pascal, in his reply to Estienne Knoll, gave one of the 17th century's major statements on the scientific method, which is a striking anticipation of the idea popularized by Karl Popper, that scientific theories are characterized by their falsifiability. In order to show that a hypothesis is evident, it does not suffice that all the phenomena follow from it. Instead, if it leads to something contrary to a single one of the phenomena, that suffices to establish its falsity. His insistence on the existence of the vacuum also led to conflict with other prominent scientists, including Descartes. Pascal introduced a primitive form of roulette and the roulette wheel in the 17th century in his search for a perpetual motion machine. Adult life, religion, philosophy, and literature. For after all, what is man in nature? And nothing in relation to infinity, all in relation to nothing, a central point between nothing and all, and infinitely far from understanding either. The ends of things and their beginnings are impregnably concealed from him in an impenetrable secret. He is equally incapable of seeing the nothingness out of which he was drawn, and the infinite in which he is engulfed. Blaise Pascal, Penns 72. Religious conversion. In the winter of 1646, Pascal's 58-year-old father broke his hip when he slipped, and fell on an icy street of Rouen. Given the man's age and the state of medicine in the 17th century, a broken hip could be a very serious condition, perhaps even fatal. Rouen was home to two of the finest doctors in France, Monsieur Dr. Dessalines and Monsieur Dr. de la Bartillerie. The elder Pascal would not let anyone other than these men attend him. It was a good choice, for the old man survived, and was able to walk again. But treatment and rehabilitation took 3 months, during which time La Bartillerie and Dessalines had become household guests. Both men were followers of Jane Gilbert, proponent of a splinter group from the main body of Catholic teaching known as Jansonism. This still fairly small sect was making surprising inroads into the French Catholic community at that time. It espoused rigorous Augustinism. Blaise spoke with the doctors frequently, and upon his successful treatment of Hen, borrowed works by Jansonist authors from them. In this period, Pascal experienced a sort of first conversion, and began to write on theological subjects in the course of the following year. Pascal fell away from this initial religious engagement, and experienced a few years of what some biographers have called his worldly period, 1648 to 54. His father died in 1651, and left his inheritance to Pascal and Jacqueline, of which Pascal acted as her conservator. Jacqueline announced that she would soon become a postulant in the Jansonist convent of Port-Royal. Pascal was deeply affected and very sad, not because of her choice, but because of his chronic poor health. He too needed her. Suddenly there was war in the Pascal household. Blaise pleaded with Jacqueline not to leave, but she was adamant. He commanded her to stay, but that didn't work either. At the heart of this was Blaise's fear of abandonment. If Jacqueline entered Port-Royal, she would have to leave her inheritance behind, but nothing would change her mind. By the end of October in 1651, a truce had been reached between brother and sister. In return for a healthy annual stipend, Jacqueline signed over her part of the inheritance to her brother. Gilbert had already been given her inheritance in the form of a dowry. In early January, Jacqueline left for Port-Royal. On that day, according to Gilbert concerning her brother, he retired very sadly to his rooms without seeing Jacqueline, who was waiting in the little parlour. In early June 1653, after what must have seemed like endless badgering from Jacqueline, Pascal formally signed over the whole of his sister's inheritance to Port-Royal, which, to him, had begun to smell like a grault. With 2/3 of his father's estate now gone, the 29-year-old Pascal was now consigned to genteel poverty. For a while, Pascal pursued the life of a bachelor. During visits to his sister at Port-Royal in 1654, he displayed contempt for affairs of the world, but was not drawn to God. Brush with death. Dubious, discuss. On the 23rd of November 1654, between 10:30 and 12:30 at night, Pascal had an intense religious vision and immediately recorded the experience in a brief note to himself which began, "Fire. God of Abraham, God of Isaac, God of Jacob, not of the philosophers and the scholars," and concluded by quoting Psalm 119:16, "I will not forget thy word." Amen. He seems to have carefully sewn this document into his coat and always transferred it. When he changed clothes, a servant discovered it only by chance after his death. This piece is now known as the memorial. The story of the carriage accident, clarification needed, as having led to the experience described in the memorial is disputed by some scholars. His belief and religious commitment revitalized, Pascal visited the older of two convents at Port Royal for a 2-week retreat in January 1655. For the next 4 years, he regularly traveled between Port Royal and Paris. It was at this point immediately after his conversion, when he began writing his first major literary work on religion, the Provincial Letters. Beginning in 1656, Pascal published his memorable attack on casuistry, a popular ethical method used by Catholic thinkers in the early modern period, especially the Jesuits, and in particular Antonio Escobar. Pascal denounced casuistry as the mere use of complex reasoning to justify moral laxity in all sorts of sins. The 18-letter series was published between 1656 and 1657 under the pseudonym Louis de Montalt, and incensed Louis XIV. The king ordered that the book be shredded and burnt in 1660. In 1661, in the midst of the formulary controversy, the Jansonist school at Port Royal was condemned and closed down. Those involved with the school had to sign a 1656 papal bull condemning the teachings of Janson as heretical. The final letter from Pascal, in 1657, had defied Alexander VII himself. Even Pope Alexander, while publicly opposing them, nonetheless was persuaded by Pascal's arguments. Aside from their religious influence, the Provincial Letters were popular as a literary work. Pascal's use of humor, mockery, and vicious satire in his arguments made the letters ripe for public consumption, and influenced the prose of later French writers like Voltaire and Jean-Jacques Rousseau. Wide praise has been given to the Provincial Letters. The Penns Wikisource has original text related to this article. Penn says, Pascal's most influential theological work, referred to posthumously as the Penns Thoughts, was not completed before his death. It was to have been a sustained and coherent examination and defense of the Christian faith, with the original title Apologie de la religion chrétienne, Defense of the Christian Religion. The first version of the numerous scraps of paper found after his death appeared in print as a book in 1669 titled Pensées d'M. Pascal sur la religion, et sur quelques autres sujets, Thoughts of M. Pascal on religion, and on some other subjects, and soon thereafter became a classic. One of the Apologie's main strategies was to use the contradictory philosophies of skepticism and Stoicism, personalized by Montaigne on one hand, and Epictetus on the other, in order to bring the unbeliever to such despair and confusion, that he would embrace God. Pascal's Pensées is widely considered to be a masterpiece, and a landmark in French prose. When commenting on one particular section, Thought 72, Sainte-Beuve praised it as the finest pages in the French language. Durand hailed it as the most eloquent book in French prose. In Pensées, Pascal surveys several philosophical paradoxes: infinity and nothing, faith and reason, soul and matter, death and life, meaning and vanity, seemingly arriving at no definitive conclusions besides humility, ignorance, and grace. Rolling these into one, he develops Pascal's wager. Last works and death. T.S. Eliot described him during this phase of his life as a man of the world among ascetics, and an ascetic among men of the world. Pascal's ascetic lifestyle derived from a belief that it was natural and necessary for a person to suffer. In 1659, Pascal fell seriously ill. During his last years, he frequently tried to reject the ministrations of his doctors, saying, "Sickness is the natural state of Christians." Louis XIV suppressed the Jansonist movement at Port Royal in 1661. In response, Pascal wrote one of his final works, Écrit sur la signature du formulaire, writ on the signing of the form, exhorting the Jansonists not to give in. Later that year, his sister Jacqueline died, which convinced Pascal to cease his polemics on Jansonism. Pascal's last major achievement, returning to his mechanical genius, was inaugurating perhaps the first bus line, moving passengers within Paris in a carriage with many seats. In 1662, Pascal's illness became more violent, and his emotional condition had severely worsened since his sister's death, which happened the previous year. Aware that his health was fading quickly, he sought a move to the hospital for incurable diseases, but his doctors declared that he was too unstable to be carried. In Paris on the 18th of August 1662, Pascal went into convulsions, and received extreme unction. He died the next morning, his last words being "May God never abandon me," and was buried in the cemetery of Saint-Achier-du-Mont. An autopsy performed after his death revealed grave problems with his stomach and other organs of his abdomen, along with damage to his brain. Despite the autopsy, the cause of his poor health was never precisely determined, though speculation focuses on tuberculosis, stomach cancer, or a combination of the two. The headaches which afflicted Pascal are generally attributed to his brain lesion. Legacy. In honor of his scientific contributions, the name Pascal has been given to the C unit of pressure, to a programming language, and Pascal's law, an important principle of hydrostatics, and as mentioned above, Pascal's triangle and Pascal's wager still bear his name. Pascal's development of probability theory was his most influential contribution to mathematics. Originally applied to gambling, today it is extremely important in economics, especially in actuarial science. John Ross writes, "Probability theory and the discoveries following it changed the way we regard uncertainty, risk, decision-making, and an individual's and society's ability to influence the course of future events." However, it should be noted that Pascal and Fermat, though doing important early work in probability theory, did not develop the field very far. Christian Huygens, learning of the subject from the correspondence of Pascal and Fermat, wrote the first book on the subject. Later figures who continued the development of the theory include Abraham de Moivre and Pierre-Simon Laplace. In literature, Pascal is regarded as one of the most important authors of the French classical period, and is read today as one of the greatest masters of French prose. His use of satire and wit influenced later polemicists. The content of his literary work is best remembered for its strong opposition to the rationalism of René Descartes and simultaneous assertion that the main countervailing philosophy, empiricism, was also insufficient for determining major truths. In France, prestigious annual awards, Blaise Pascal chairs are given to outstanding international scientists to conduct their research in the Île-de-France region. One of the universities of Clermont-Ferrand, France, Université Blaise Pascal, is named after him. The University of Waterloo, Ontario, Canada, holds an annual math contest named in his honor. Roberto Rossellini directed a film biopic, entitled Blaise Pascal, which originally aired on Italian television in 1971. Pascal was the subject of the first edition of the 1984 BBC Two documentary, See If Faith, presented by Don Cupid. See If Faith, presented by Don Cupid. See If Faith, presented by Don Cupid. See If Faith, presented